All right, for question 2, what we need to look at is the amount of time that it takes to go a single rotation around this record. And for that, obviously the distance is 2 pi times r. The time is the amount of time it takes for a single rotation, and this gives us the speed. We can figure out the time for a single rotation by taking the number of rotations per minute and converting that into how much time it takes for a single second. So the time is equal to 1 over 78 times 60. We'll just keep that as a full value and plug it into our formula. So 2 pi times r, 0.15, divided by 1/78 times 60. Pulling all this out of the equation gives us 1.23 meters per second. In B, we want to convert this into an acceleration. AC is equal to v squared over r. So 1.23 squared over the radius, 0.15, gives us 10.1 meters per second squared. For C, we want to know the frictional force that's required to keep that spider on the rotating disc. What you have to realize is that as the disc is rotating, the force that keeps it on there is the frictional force directed towards the central axis of the rotation. Excuse me. So what that means is then that F, force of friction, has to equal Fc. And that means then that the mass of the insect, 0.001, multiplied by the acceleration, which is the net acceleration of 10.1 meters per second squared, has to equal the force of friction. Just like that. 1 times 10 to the negative 2 newtons.